Hey there. Let's see. Let's look at the unit circle. So we got the unit circle, and really what we're looking at is the unit circle, the coordinates of the unit circle as we're going around it. Remember that this unit circle has a radius of 1 as we're stretching it all the way around. So I'm going to put still images of this and of this, but I'm going to recreate this in this video. The one thing that I'm not going to recreate is the math that's on the side. So I'll pull this paper in every now and then to look at the math that's on the side. I want to make this video like a faster version to help students see stuff. Here's the thing though. As we go around the circle and we get these nice degrees of 45 degrees, 45 degrees, if we drop from this point straight down, we get a vertical that creates a 90-degree angle. We get a 45, 45, 90 triangle. But the nice thing about that is that there are some special properties with the 45, 45, 90 triangle. And it's that like it has equal sides because it is half of a square. You take the square, you cut it in half, and you know that the two legs of this have to have the same measurement. Now that becomes a handy little thing. So let's go blank. Let's go with a blank piece of paper here. And as we look at this, remember we've got this 45-degree angle. And as we take that angle and we say, what are the coordinates here? That's what we want to look at, is what are the coordinates for that point. Here's the thing. Let's just go around the circle. If the unit circle is a unit of a radius of 1, 1, 1, 1, then this length right here has a length of 1 unit. And so does this one, and this one, and this one. And as we go around and we think of like, well, what's the x? Look, remember, this is an x-axis and a y-axis that's on top of the circle here. So as we go over to this point right here, that point would be 1 unit over 1 comma 0. And as we go back to the origin, the coordinate here is 0 comma 0. It is nothing. And as we go up to here, this would be 0, 1, and as we go back, this would be negative 1 unit, so back 1 unit, 0, negative 1, 0, and here would be 0, negative 1, going down 1 unit from the origin. This point right here, it's going to have an x value, and it's going to have a y value over here, okay? And this is where thinking about that 45, 45, 90 triangle, 45, 45, 90 triangle, we know that this length and this length are going to be equal. That means that the x value and the y value over here, actually I don't necessarily want to do that. I'm just gonna get rid of that little stray mark right there. All right, but this length and this length, the x and the y values will be the same. Now, what we saw was, because this was 1 unit, and if we did 1 unit, and then these missing sides were the legs, and we did 1 squared and x squared for each of these legs. If we use the Pythagorean theorem, we combine these. We did some math in class, and we found out that the missing side length, if this is 1 unit, would be the root of 2 over 2. So this length right here is root 2 over 2. That's how far away from 0 it is. And that also means that this height right here is root 2 over 2. It's like, how much is that? Remember, this is 1 whole unit. Well, the square root of 2 is 1.414. And if we divide that by 2, we get 0.707. You don't need to remember that. The square root of 2 divided by 2 is about 0.707. Forget that 7 there. Let's see, 0.707. Here's the thing, is that you should know that it's going to be less than 1 whole. 1, it would be here, and 0.7 would be, about 3/4 of the way, over. Anyway, so the coordinate for this point is going to be that distance of root 2 over 2. We leave it as a radical because that's the exact value, no rounding or anything. And it also makes it nicer to memorize, root 2 over 2. Now, here's the thing. We see this triangle, that's like our initial little triangle here to create the coordinates for that point. But what about this point over here? Well, this point is going to have a little right triangle as well, if we look at that, where this length is going to be equal to that. Like, oh man, so this x coordinate right here is also going to be a root 2 over 2, but because it's behind 0, it's going to be a negative. negative root 2 over 2. The y value says it has the same height as this, so it's still root 2 over 2. Do you guys see the pattern with this? We're just taking the same numbers, going all the way around and saying, hey, well, the x would have to be negative and the y would have to be positive here. And as we go here to this point down in this quadrant, both of them, negative and negative, negative root 2 over 2, comma, negative root 2 over 2. That's got to be the coordinate for that point. And as we go over here, well, the x value would be positive, but the y value, this height, that would be negative root 2 over 2. That would be a negative value. So we would get root 2 over 2, root 2 over 2, but the y value would be negative. That's it. That's it. Now, there we go. So that's how we fill in that circle. Now, if we then look at this one's not split up into 45s. So this angle right here is a 30-degree angle. If we do the same type of thinking, dropping this and saying how far over is this? What's the x value, and what's the y value for this? We're asking what's the height and what's the length, what's the height for this little right triangle? But it's a 30, 60, 90 triangle. 30, if that's 30 and that's 90, this has to be 60. And I don't have the notes on that side. I have the notes on this side. Remember that a 30, 60, 90 triangle is half of a isosceles, half of an equilateral triangle. Okay, so we take that, we split it in half. And this short side here is half the length of these equilateral sides. So let's actually use that here. And so here's where I'm going to draw. I'm going to draw in this triangle right here. I want you to see that one, but remember that if we copy that one over here, down to that point, we copy that one. What do we get as a large triangle? We get an equilateral triangle with this and this and this are all equal. Well, here's the thing. What's the length of this side? It's 1 unit. What's the length from here to here? This is 1 unit, but this would be half. This would be half a unit. And this would be half a unit if you split it in half. So here's the thing. Out of this triangle, we now know that the y value would have a height of a half. And that means that if we take that height over here, that means that this coordinate over here would also have a height of 1/2. Okay, so what's the length of this side length? Okay. So by the way, before we even do that, what I want you to also see is that if let's go with the next point here, this one right here. Well, this is going to get cluttered if I do this all in one space. So, but I still want you to follow along here. What if we turn that? Now this would be a 60-degree angle, a 30, 60. All right, so again, at the risk of making this too cluttered, a 30, 60, 90, this is still 1 unit. And if we were to copy this triangle over here, we'd get an equilateral triangle where it's 1 unit, 1 unit, 1 unit. All right, and this length right here would be half of that. So this one right here, this would be 1/2, but it would be for the x value, 1/2. If we take and we reflect that over here, that means that this one, when we drop a vertical here, the short side, this x value would be 1/2 of a unit, 1/2 of a unit, but it'd be a negative 1/2. So that means I know the coordinate for this one has a negative 1/2 for the x, not for the y. Here the height was that short side. Here the length is that short side, the x value. Here's the thing, if that's here, we can just keep going around here, and we know that now this one has an x value, this point has an x value of negative 1/2. And if we look over here, this point also has an x value of positive 1/2. But wait, we can also find the y values for these, because if I take this distance and flip it down here and cut this in half, this point right here is going to line up with negative 1/2 on the y, so the y value would be negative 1/2. Negative 1/2 for these. They have the same height. Look at that. Look at how we were able to logically fill in all of those. That is a way that you could attack, the unit circle when you take the quiz or whatever on this, or when you're trying to find these. Now, to find this longer side, we did some math. And we used the Pythagorean theorem saying 1 and a half, and we did 1 squared is equal to a half squared plus a missing side squared, this missing side squared. We did the math, and we found that that long side would be equal to the root of 3 over 2. Similar to this one, root of 2 over 2, but now it's root 3 over 2. The way I remember it is that all of these 30, 60, 90 are divisible by 3. They need this one's going to have the root 3. This one has 2 equal angles, 2 equal sides, 2, 2, 2. This has got the root 2. Okay, so this length right here on this x value is going to be root 3 over 2. Now if we do root 3 and divide it by 2, we get 0.866. Now that means that this value right here going across is about 0.866 units instead of 1 whole unit across. It should make sense. It is a long leg. So this long leg here, root 3 over 2. And when we look at this one, now we know that the vertical height, the y value here is root 3 over 2, and we can get this vertical height, root 3 over 2, and this one over here, root 3 over 2, because that's at vertical height. It's the long side. The y value is the long side, the x value is the short side for this. You want to see triangles. Now when I come over to here, the long side, going back to negative root 3 over 2, is going to be the x value, negative root 3 over 2. And that's going to be the same x value here, negative root 3 over 2. And this y value gets reflected down, and the height of this point and this point is at negative root 3 over 2. So that's negative root 3 over 2. Okay, negative root 3 over 2. And this last one, its x value is this positive root 3 over 2. Okay, man, so 12 minutes. Hope that made sense as to like how we derive this and how we find every single coordinate. Play some of the games and stuff like that go along with this that I've linked in Google Classroom, that link this together with our discussion on degrees and then our discussions on radians. All 3 of these together go together to complete the unit circle. You should be able to break the unit circle up in degrees, in radians, and find the coordinates for every point here. All right, take care.